morning. Welcome to Startups in Asset Management Technology. We have a great session planned for you. Really excited to be talking about this topic today. There's obviously a lot happening in the space. And we're very lucky that we have Ryan from Willow with us and Jack from Orbiseed. And hopefully we'll be having Troy from PassiveLogic join us as well. So three guys working at various, totally very different areas within the same space. And so they are, their companies and their roles are quite different, but also there's a very strong through line connecting it all. So looking forward to the discussion. Before we dive into that, just a couple housekeeping items. One is for any Q&A. So on your screen, you should see a couple tabs for chat, Q&A, polls, and handouts. In the handouts, you'll see a couple things that Ryan has uploaded about Willow. So please feel free to download those and read them at your leisure. Chat, in the chat tab, that is, if you enter something there, it will be seen by everyone. And so that's sort of, if you just want to make comments, socialize with each other, feel free. The Q&A, that is if you want to ask some questions. So please go ahead, enter questions in the Q&A. They will come through, I will see those, and I will, once I see those questions come in, I will publish them. When they're published, you'll be able to vote on them. So the more, this will help us sort of float the most popular questions to the top. So please do vote on those and just engage there. And any and all questions are welcome, and look forward to seeing those. Looks like we have Troy coming in and out, so hopefully he'll join soon. Give you a bit of intro to myself, Brad Keast. I'll be your moderator host this morning, and I am with a company called Dream. We're based here in Toronto. Dream is a platform of 4 publicly traded companies. We have, across the platform, we have a wide range of asset classes, a lot of commercial, residential, industrial, predominantly focused in Canada, but we do have, through some of our platforms, we do have significant assets in the US and in Europe as well. My role is innovation and development. And so my background is within real estate is on the development side. Before that, I was a graduated with an engineering degree. I was in the Canadian Navy for 9 years doing combat systems engineering. So have really a sort of a technical and systems engineering approach within real estate, have the development side, and now sit in a role that straddles asset management and development, is talking a lot on the innovation side through people internal and external. So I think have most of what we'll cover today. I have at least enough knowledge to be dangerous and ask possibly inappropriate questions. So that's where I'm coming from. Want to turn it over to our panelists now just to give a quick intro of who they are and their companies. So Ryan, let's start with you.
Beautiful. I'm just going to share a few slides, so please let me know if it does come through on the screen for everyone. I'm just going to say hello. My name is Ryan Wakefield. I do work at a company called Willow. I'm very excited to be here, part of this panel today, and joined by other leaders in this space. So I want to thank CanBIM for hosting this great event, and also thank you, Brad, for moderating this panel. Willow is a technology business, and we deliver our digital twin solutions to a global customer base of owners and operators in both real estate and infrastructure. Our headquarters is in Sydney, Australia. This is exactly where I started back in the business in the early days of 2017. And we've actually matured and grown a lot over those past 3 years, but we still proudly claim that startup title. So I just relocated back here to Toronto, which is my hometown. We're rapidly growing here in North America. We've established offices in New York and Seattle already, but we're here to also address the customer base we have in Canada, which is growing quite significantly. Now, our roots as a business are both in real estate and infrastructure, And a large part of our business has grown off the back of our services work. So doing digital engineering, modeling, architecture support, and consulting. And as we support our customers on major complex projects, it was actually how we developed a close relationship to help take that domain expertise that we have internally and develop solutions that we know will be driving smarter operations for the assets themselves when it comes to asset management and operations. Our core platform is the Willow Twin, which is something that I'll just touch on briefly. It's primarily used as the platform for operating assets in commercial and corporate real estate. Our Willow Twin is the digital twin for the built world, and it provides that single interface for actionable insight for all asset data, spanning across business functions and project stages. Let's quickly move on to the next one here. Particularly in real estate, a lot of our conversations have transitioned from how do you take a smart building to look across a whole portfolio? How do you make a smart portfolio strategy? And we really work on helping create that environment that enables that quality, structured information to be available to decision makers across an organization. We believe that digital twins are core to the answer to address a lot of the fundamental challenges that we see in data today that I'm sure we'll speak on with Brad in a few minutes. Now, this process of creating a digital twin through the asset lifecycle, we understand that there's going to be an interface for operations. That's what we provide to our customers. And ultimately, through our marketplace, we could extend a lot of that data out to other global leading partners. Willow, at its core, doesn't do everything. You know, we hear digital twins, it's a big buzzword at the moment, but we actually rely on our partners as well to extend that data out and provide more value to owners as well. Now, that's in the real estate space. I'll quickly summarize my final point here, that in infrastructure as well, we're doing this in rail. So for rail asset management, we've developed a solution for rail operations in both heavy haul and passenger rail. At its core, it's the same problems that we're looking at, but it's specifically about creating that single application layer that operationalizes all that live, static, historic, and geospatial data that are currently not connected today into a digital twin across an entire network. We sit in the business technology stack. We bring together all those systems into a single tool to be used for more effective decision-making and asset management practices across the rail network. I understand that was a quick fly-through, but I think that'll be my piece for now. So hopefully we can touch on a little bit more what Willow does in the future. But as was mentioned by Brad at the beginning, there's a handouts tab. So if you want to get any more information, I'll just point you in that direction. So that's my intro, and I'll hand it over back to you, Brad.
Great. Thanks, Ryan. Good overview. Jack, let's move to you.
Sounds good. Let me just turn on the slide here. All right. Hi, everyone. My name is Jack. I'm the co-founder and CEO of Orbiseed. We are started that when the really incorporated last year, April 2019, and we went through a lot of hyper growth in the previous 18 months. So when we started, we were starting as a 3-man team. There's me, there's my co-founder Jim, and Ting Chen, and we were in the basement of my apartment. That's how we got started. And then a year later, we expanded to 14 people. We were having our own office, and we got accepted into one of the most well-known prestigious accelerator in the world, Techstars. And we recently graduated actually from Techstars in September 2020. And right now we're growing as well. And we're looking at actually scaling our team, doubling our team in the next 12 months as well. So quick note on what we do at Orbiseed. So as Ryan already mentioned about Willow in the digital twin space, what we do is we aggregate data and standardize the correlate and extract the different diverse sets of data sets. So we don't actually provide the data sets, but for the companies that does have the data, we help companies figure out how to utilize the data to provide better, faster, and more affordable business insights. So what this means is we have an AI technology that takes in the data, highlights what's important, and put them together and to link them to see where it can be helpful, almost like a smart AI consultation service for your data. We act as a data scientist for your asset team. So there are 2 use cases right now we work on. So the first one we found is actually how Orbiseed got started, was in the fire protection industry. Now, fire protection, in fact, Orbiseed got started when we got approached by a fire protection company looking to 3D model and visualize all fire protection data within the city of Shanghai. And right now, it's a very manual process. So in order for them to check for fire safety, they will have to look through each drawing manually and read through, find out where the designs are breaking the fire code, what new design options can be implemented, and are there additional fire sensors for any mishaps, or do simulations on the drawing. So what we end up doing is we train the AI process that reads CAD drawings and define and helps the engineer, fire protection engineer, identify where are their lack of good design options in design code, and highlight them in a 3D model that we automatically generate using our AI. Now, this is a process that would normally take many days for a 3D modeler. By using AI, we were able to do this in less than 5 minutes. Oh, slide this one down. Yeah, here we go. And so the second use case we're right now working on is document analysis for risk engineering. So this is a process where many of the risk engineering are spending hours trying to read through technical reports, risk analysis reports, engineering specification documents, which could be 100 to 1,000 page in length. But the data they need exists somewhere in there, but they only need 10 pages of it. So using natural language processing and computer vision, we extract the important information from those documents and give them a quick summary that they can read through in 5 to 10 minutes, instead of having to search the entire document for the information they need. Now, this is, we don't provide the documents, we connect directly into the system and the asset management systems that different companies use. So that's in a whole where Orbiseed works. A bit of background from myself. I recently graduated from University of Waterloo, mechanical engineering. Well, by recent, it's pretty recent, I would say, for many people here. But so 2016 being 4 years. And I originally was planning on going to engineering, oil and gas. However, during some of my internship experience there, I realized that I got an engineering degree to find number of knobs on a sort of engineering diagram, and that just wasn't very fun. So I ended up, that really intrigued me to say, can we do this more efficiently? Why did that, we need a 4-year engineering degree to try to look for values, right, on engineering drawings. And that really started the journey for me to explore how we can do this with a newer technology and solve the problem of engineering. Thank you.
Thanks, Jack. Troy, welcome. We'll hand over to you now for a quick intro.
Yeah, so I'm Troy Harvey. I'm the CEO of PassiveLogic, and as you can see, I'm in a stairwell, so it sounds like I'm in a stairwell. There were a little mishap at the office here, and that I don't have my key, and everybody's out for COVID reasons. So, so you'll have to listen to a little echo here. But let me give you an introduction to PassiveLogic. So PassiveLogic is the first autonomous platform for buildings. To make sense of that, it's like taking the brain from an autonomous vehicle. Instead of teaching it to drive, we've taught it about buildings, building physics, how buildings work, how systems work, how humans experience comfort, and so forth, so that we can provide that real-time automation in a building that's always optimal. And we've taken this platform and we've rolled it into the one thing that all buildings need, which is a control system. When we think about the different pieces to this puzzle, first is the platform, this new type of control automation system. It really wraps up a lot of these different fields, this value chain of buildings, into this pluggable platform that can connect into the systems we have in buildings. The core goal of PassiveLogic, beyond making buildings actually work well, is to democratize building automation and to democratize control so that every building can have this type of technology. So BMS is not just trapped in the top 3% of buildings. we think of this core customer, this opportunity in buildings. We affectionately call this guy Boiler Bob or HVAC Harry, while the rest of the value chain is often pushing on a rope trying to get things to happen in buildings. The reality is buildings are built by guys like this. And so we really need to include them in the technology stack if we ever want to change the platform in buildings. The other key piece is what we call Autonomy Studio. It is our software platform that allows average users, whether that is an engineer or even an architect on the maintenance management side, or that's HVAC installer or controls installer, to build their own autonomous system for their building. And this is what's unique about buildings, is unlike cars, every building's a unique platform, right? Every building a unique and really what we enable is the average user to very quickly construct, draw what their building looks like, draw what their systems look like, or import their CAD or BIM, and we build up these digital twins around that we can control that building. Technology called deep digital twins. This is recently we got $1 million backing from the DOE to build the digital twin standard around buildings. And where deep digital twins take digital twin, the digital twin is the AI into the hands of whether it's Boiler Bob or the engineer, the ability to draw their own systems and essentially can construct their own AI system to control and maintain and manage that building. So these deep digital twins, they understand their own behavior, they understand their own physics, they know how to translate in and out of different protocols. They're able to learn locally, which is unique for AI systems, and it can form an interchange format that we can share amongst ourselves in the industry. And then finally, this digital twin interface is not just something that we can trade around as a file format or that can be consumed internally by an autonomous system, but performs what we think of as level API for buildings. So till now, we've just had these very, very low level systems, and it's up to so we really make that an automatic process as a free side effect of getting the control system that you need by the nature that this is the requirement to make a building go. Thank you.
Great. Thank you. Again, all very interesting, very different, but still a very strong through line through this. So I think to really kick off the discussion, because this conversation could go in so many ways, let's start sort of shaping it a little bit. Let's talk about a little bit the sort of the problems and a little more about the technology of how things work, and then also we'll want to shift gears a little bit and ask just some more operating your business type questions and sort of how it came about, challenges as CEO, et cetera, et cetera. So Ryan, let's start with you, just because in part because Willow has been around the longest. So what problem facing asset managers are we trying to solve here?
Yeah, it's a great question. I'll do my best to kind of lead it off. I think it's something that we're all trying to solve in our own unique ways, but I think the majority of conversations that we're having with asset managers is about that bigger problem of too many systems, too many data sources that don't communicate with one another, especially across the asset life cycle. When you acquire a new building, there's massive data loss. Customers are now looking for a solution in asset management that can help consolidate and simplify this. It's a very complex world. As you throw in a new technology, it's a new problem to deal with. You have to kind of put it all into context and understand where you prioritize your time, where you make your investment decisions. And they're looking for that single view of how a single building is performing, and then also extrapolating that across an entire portfolio of buildings. And I think we've actually seen that shift actually broaden a little bit more, because now in 2020, we've had to adjust to remote working. And now we're looking at a place where we could actually digitize our assets, capture all that information, and be able to leverage that and make decisions no matter where you are, especially across an organization. Just getting that information and insight into the hands of the right person is a huge challenge.
Right. So let's dig a little bit deeper. So one of the things, so you talked about trying to link all these different systems together, which I absolutely can appreciate. There are such a wide range of systems out there. So what are your top priorities? Like, which ones are you connecting to now, or are you looking at connecting to? Like, what are the highest priority, highest value ones that you see there?
Yeah, absolutely. I think at its core, you look at the simple things like the asset registers, you look at maintenance schedules, work orders, you look at capital planning, also integrating into a BMS if it's accessible. If a building's connected to the internet, if you can actually find a way to connect to that building, that's a huge win. But it's also about defining the use cases and understanding, well, are we going to look at space utilization, or you want to look at actual lifts and lobbies when they're being occupied? Especially now the conversation is shifting as people are trying to return back to work. So it depends on what the output is that you want. You look at what the core systems you want to integrate with. But I think essentially what I mentioned around the asset registers, the BMS, that's probably stage one. And then you'd probably build up a digital twin at different stages. You'd have like a bronze, silver, and a gold. And I think that all of us would love to kind of strive for delivering a gold solution to our customers, but every building is unique, like Troy mentioned. So you have to kind of identify the best you could do on day one and build it up from there.
Right. Okay. So Troy, going to what you were talking about the idea of deep digital twins versus digital twins. So let's talk a little bit, explain sort of either the similarities, differences between PassiveLogic and Willow, because the way coming into this, the way I understood it would be someone like Willow provides a digital twin. You almost layer on top of that as sort of the automation system. And then I have a number of questions of just how that relates, how those two functions relate, and then how you would relate to things like your building management, automation system, et cetera.
Right. And that certainly can happen, right? We can certainly layer on top of a Willow or go the other way, right? And one of the values that we see in the automation-based approach is sometimes it's how do you get all of that information you need for a building to go? And often that's orchestrating the architects and engineers and getting all the data, getting the data from different resources. Effectively, what we've done is tricked the building automation installer into making digital twins for us by trading them for something they don't want to do, which is program. They probably don't know how to do it. And instead give them this drawing environment that they're building up this digital twin. And that allows us to then export it to other places. But if there's that data that exists, if it's coming from a Willow, it's coming from a Ben. So that's the first sort of point of definition, is like, how do we get digital twins in the first place? But in terms of how to deep digital twins versus digital twins, so I think digital twins really evolved from the concepts of BEM, right? We took 3D CAD, we started naming things, we gave them a little bit of symbology, we could attach data points to them. But for PassiveLogic's purposes, just for us to get off the ground, we needed something more than that. We needed digital twins that could describe themselves, that have this term that we call an ontology, which is a nerdy word, but it's basically technological existentialism. How does a pump know what a pump is? How does a pump know how it connects to the world around it? What does a pump know about itself? And how can it describe its own control and therefore its own maintenance and management? And so this knowledge, this self-knowledge, is really crucial to do any really sophisticated principle to AI work. And that's core for doing control, but it's also core for how do buildings describe themselves to their building managers.
Okay, interesting. So thinking around the component existentialism questions, what am I as a pump? How much of that is on you, do you feel, and how much of that is on the pump manufacturer and other technologies that they may integrate into their product off the shelf?
Yeah, so there's two really important points there. So one of the great things about having AI in the building, in an autonomous system that's interacting with a pump, is it only needs to know that it's a pump, and over time it will understand what that pump is. It can learn locally. This is very unique for AI. Most AI that we buy, right, whether that's your iPhone recognizing your face or if you buy a Tesla that can drive, it's not learning. It has been learned. And it is given to 100,000 customers or 1 million customers, all exactly the same, right? So what these deep digital twins enable in this new kind of AI framework for buildings, it allows it to learn locally. It learns what your building is. And that provides richer data around that pump or your building assets to then extract and give to the devices or services that are layered on top.
So as it's learning itself and learning locally, I trust there's still some way that it's tapped in to sort of a network, or it understands how other pumps potentially are operating, because over time, in my view, I think a lot of this feeds into your capital planning. So for instance, someone will come and say, okay, this pump should last, called 7 years. But through diagnostics of this pump knowing how it's doing versus how other pumps have done and their time to failure, can that feed in somehow to your capital plan to make things easier? And if so, are we there yet, or when will we be there?
Yeah, we're there yet.
Okay.
But one of the important things that I think when you think about digital twins, they're largely a component to themselves. But the deep digital twins, because they understand behaviors, and they also understand this other concept of actors. So what is my role in a system, and what are the behaviors? What is the underlying physics that makes me go? Why this is important is when you take a pump and you connect it to a boiler and connect that to a buffer tank and whatever other systems are in your topology, those interacting together describe something even more than any one of those things. And to your capital plan, all of a sudden you can start to observe things about the pump that you wouldn't have been able to observe if you just had that physical point of turning on and off the pump. You wouldn't have seen the other points of wear in that pump that couldn't be described by just the pump itself or the data on the pump, because there's 30 or 40 other variables of the physics of that pump that can only be extracted in action or interaction with the rest of the system. And that can say, oh, wow, this pump is starting to fail. It's not working the way it was. It's starting to degrade from its internal physics the way that we've seen it operate.
Right. Right.
Now I can go replace it. Right.
Right. Exactly. So now if we imagining that's just one pump, and now there's however many thousands of components in a building. Now, Jack, you come in and you somehow aggregate all that for your risk engineers. Walk us through a little more detail, just of what info is useful, how those risk engineers do it, and what the ultimate benefit to the owner of the building is.
Absolutely. So one of the things about digital twins is it collects all sorts of data, and then the people who are working on the pumps want to know, what does this mean, right? So based on all the document, that manufacturer document, all the specification document, all the information about previous maintenance orders, what does all this mean? How can they use this information to benefit them? Now, the current way to do it is analysts will be hired to look through all the documents and try to put together a summary. So to find the relevant information you need. So speaking back to my previous job as an intern at the oil and gas company, my job was focused on pressure gauges in an oil and gas plant. So my job was to, okay, now if I want to figure out what design we need or what maintenance information we need, I would to look through all the documents from different suppliers, different manufacturers, and different maintenance order, and try to list them all in an Excel sheet. Now, that is something that's still done currently by human. And a digital twin is only effective when it's updated consistently. And that right now is a lot of manual effort. So what Orbiseed is really working on is, can we replace that co-op student or my previous job with an AI that automatically goes through those documents and find the information you need? So so it's almost like a Google, but for all your base data documents. So if you want to know, okay, when was my pond last maintained? Instead of trying to find through silent documents and find out where that information lies, the AI will search through that for you and highlight to you where to find this information. Now, and also automatic process information so that this information automatically enter into a digital twin system instead of having someone going there, open the digital twin, looking at the documents on PDF, copy and find the information, enter it in. So this is really what Orbiseed is how do we make sure that digital twin is cost effectively and quickly maintained? And how can we take all this information that's already existing and quickly give out a summary report that's specific to your business needs?
Great. So in that, often who are you most engaged by? Who's your client in this?
Yeah, so in the risk engineering business, the risk engineers often serve the insurance carriers. Now, insurance carriers want to know what's in the building because for them, that's important for them to know how much premium to charge, what is the maximum potential claims that they'll lose if a fire happens, or how likely the flood is going to happen. Now, they have to do all this information by sending out the engineer on the field every year to look for different information, any changes, any updates, and this is information all updated. Now, on the financial side, this is very important because the underwriter cares a lot about this information. However, all the engineering side is also about the manpower that's used. So very often, engineer, even though the value comes from the carriers, they're trying to do this at as low of a cost as possible. So often engineers would have the issue, right, or face the problem of, I have 30 days of work, I have like 2 people on my team, and I have to do this very fast. So they're overworked and raw data and very prone to human error, because if you make a mistake on the numbers, no one's really gonna know unless it goes through the entire process all over again. And so even though, we sell to both sides, the insurance carrier themselves, who are ultimately looking to lower cost, and the engineers, the engineering companies, the risk engineering consultant companies, who are looking to do this faster and more accurately.
Right. Okay. So Ryan, let's bring it back to you. We've got, so now with all of this info, so there's a lot that we can do that on sort of what's existing. How does this feedback, and how do we take all this info to now streamline actioning it from the design, costing, construction piece of that cycle? Even so, if we find problems or challenges that need to be done, how do we, either within the existing building, or also another sort of part B to that question would be, how do we take all this learning and help our next generation of buildings be designed better from day one?
It's a great question, and I think we saw that journey live out with one of our main customers in Australia, Invested Property Group. We actually started the journey in design and construction, defining what a smart building is, what a smart outcome is. So what do you actually need to operate your building smarter in the future? And actually being able to put those in as requirements through the supply chain, so you could actually have a smart outcome. You have a digital handover of your building. You're not going back to using clipboards, walking around site, doing manual inspections. So what we've actually been able to do is take that journey of, let's define what a digital twin is for operations right at the very beginning of the asset lifecycle. Let's deliver that for operations, and let's see what we can learn from that and be able to take those learnings and apply it into the next stage of what's the next development you're looking to build in the city. But of course, there's going to be different journeys and different paths you go on, because as a customer sees the benefit of digitizing their asset, they want to go for their existing portfolio. You may not be able to get to that gold tier, like I said, of a digital twin, of the ultimate version of what a digital twin could do for you in operations. So you have to understand what are the actual use cases for them, and what do they need to see across a portfolio to enable better decision making. But it's all about getting that alignment across the various teams. Typically the development guys don't speak a lot to operations guys. That's pretty standard across the industry. So what we actually need to do is find a way to actually remove those barriers and help and technology to enable that conversation to happen, be able to show the real benefit, the real ROI of adopting this technology, and then implementing that vision right back at the very beginning when possible.
Right. Okay. Now, Troy, in terms of as going through the design and deciding to implement one of these systems, as we all know, there's always that tricky balance between the scope and the budget and the schedule. And different companies and different people have different approaches. I think most often, I think budget comes first, and then scope, and then schedule. What are you, from your point of view, what have you seen where clients probably maybe make the biggest mistakes in terms of a compromise?
Well, I think if we look at this industry, we can kind of look over the arc of the challenge with respect to what you're talking about, is that we've tended to bring technologies into the market as an upsell on some feature set or value that we're hoping the customer has. Do they care about energy efficiency? Do they care about operational value? We've taken a thesis that says we don't want people to care about those things. We want them to, we expect them to behave the way they behave, right? And that is cost will reign. And if you don't get your technology into the beginning of the cycle, if you don't solve the core problem, what's the core problem? It's really, how do we get these things into buildings in the first place? And so that's what we've really focused on, which is why we talk about this first side, this design build side of the marketplace. We've really focused our technology on really building a user experience for these industrial customers who are going to put a control system into a building. And we give them a control system of equal cost that scales up and down, whether it's skyscraper level or the little corner coffee shop, that's competitive in price to what they would normally be doing, but make it so that it's 10 times less effort, less programming time, less install time, less commissioning time, and using that automation, not just to automate the building, but to automate that whole design build side of the business and really give away all the value chain that happens afterwards. And we think that's sort of core to how do we get this into all the buildings, as opposed to when we ask people to integrate another technology, we're really shrinking the market, right? They're already struggling just trying to do BMS. That's shrunk the market from 100% of commercial buildings down to 5% just to get to BMS. If you're stacking on top of BMS, you're shrinking another order of magnitude and you're like less than 1%, right? So how do you get to that 100%? Well, you have to make the user experience for the people actually doing the work at the front side of the building operations, installing things simpler, easier, faster.
And how do you do that? I think you're absolutely right. The implementation is always a challenge, and especially, and it's a question that I would put out to any of you. But and we can talk about. We'll park that. We'll come back to it. But how do you engage sort of the people? And saw another interview that you gave where you talk about people walk into work with 2020 in their pocket, but then they're operating something that was 1985. So the people that are comfortable in 1985 technology, how do you sort of make that hyper leap to what you're talking about?
Right. I think, this marketplace is just at its precipice of starting to accelerate. So when we look at the car industry, we've gone through 15 years from 15 years ago, you had guys like Elon Musk talking about autonomous cars, and people are like, what are you talking about? Vehicles have been a static industry for 100 years, no new players. And then all of a sudden, people start getting it, and they start getting the implications, and not just how we drive, but the ripple effects around the surrounding economy. We think that PassiveLogic, that the ripple effects are even stronger in the building industry. The implications in terms of energy are way larger than they are in the vehicle industry. But you have to start at this point of engagement at who buys. Well, it's not actually most of the people probably listening to this, right? What happens in the value chain is a REIT or a maintenance company will engage on the existing building side with companies that do the work. And on the new construction side, a REIT will hire an architect who hires an engineer, who hires a general contractor, who hires a subcontractor, who sends a guy in a blue jumpsuit in a truck to go buy something to put into a building to make it go. Well, this problem of what are they going to buy to make that building go, effectively, all the technologies out there today, it's not just they're really designed in the 80s or 90s, and they're these 30, 40-year-old platforms that they themselves, all they are doing is basically emulating 150-year-old thermostatic technology that was invented in 1850. And the latest technology they've implemented is something called PID, which was something invented in the 1920s. And that's all they're wrapping up in this digital platform. And it's no wonder that buildings are struggling, because it turns out we're fooling ourselves. We're not telling ourselves the whole story about buildings. Turns out buildings are the world's most complex robots. Take that autonomous vehicle we've been talking about. It has 40, 50 sensors at max on the front end. And then it controls turn left, turn right, accelerate, brake, 4 outputs. In buildings, we very easily have 10,000 to 100,000 sensors. And on the control side, on a small building, it can easily just be, in the hundreds, but it goes up to tens of thousands. So that level, that scale of complexity of inputs and outputs, there's no other system in the world that does that. And we're still trying to control it with a 150-year-old technology. It's why every building project is a crap show.
Right. Yeah. So, and have some questions that we'll come to on this. We could probably be here for 7 hours, not one. Want to pick up on what Troy was saying though, Jack, and bring it to you. There's a very small number of buildings that even have the technology that you need as base infrastructure to realize the value that you offer. So how has this experience been for you, and how are you working to try and find ways around over or through that challenge?
Absolutely. It's 100% correct, right? So in order to build technology on top of technology, you need the previous technology to be there. And that has been the same process being going on with a lot of technology trend, which has been one of the reasons why adopting technology is so much more difficult, because each time you already adopt a technology, it's already outdated, and you're now looking at the next one. And people are just not, afraid of, okay, so if I learn this, will this be completely out of date when I have it fully implemented? Now, what we look at is, okay, now what if instead of having technology solve a problem, if a consulting company was to go in there and do all the change management, assuming the consulting company has unlimited manpower and unlimited budget, what could they do? And we look at it, okay, we will study what they currently do and try to figure out where the market is right now, and try to do that change of how do we take your existing data, what new technology do we implement, and give you advice on this is the new things you need to put in, this is the process you need to change on your documents, and that's how you take your current documents and digitalize them in a way that's suitable for the new technology to work. And then we look at, okay, so what, and that was actually my really intern job for the most part, right? That for every one engineering company, you need 7 different analysts or juniors and intermediate to do all this work, to figure out, okay, how do I take what the engineer has designed and apply it to all the, the CAD drawings, to build into a BIM model, to really integrate it with the different sensors and IoT devices. But recent advancement in AI and natural language processing, computer vision, had made that automatable. What this means is you can now train an AI to read the type of documents that the engineer already work with. And it can automatically, you can scale this up to hundreds, thousands, without having to pay extra salaries. And AI never sleeps. They make more accurate decisions, and they do it significantly faster. So now you basically have that ultimate goal of you have an unlimited budget, unlimited team, unlimited workforce that never sleeps, and do it at affordable prices. And you implement on top of people's current workflow. So this way, the engineers can still do the way they feel the best, the most comfortable, with papers, with drawings. And of course, there are still some ways to adding in new technology, but the AI take care of most of the everything afterward to integrate. So this basically bridges the gap between what's currently done and what you need to get done.
Okay. So as we're talking through this, and the idea of a couple of things jump out. So the idea there's upwards of 100,000 sensors in this building. In a sense, obviously that's significantly more than a car. And then the question is a car operating in maybe a bit more of a complex environment because it's always moving, or like it's physically moving and going through all sorts of different conditions. The building, although it's not moving, there's tons of things changing. So obviously that's very complex. And we've talked about how every building is different. So bringing back, Troy, to your car analogy, it's almost like if you want to build a building, you're ordering a whole bunch of parts, and so convert to a car. I want to buy a new car. Over a period of, I don't know, a year, an entire team designs this car. It's custom just for me. It fits and sits in my driveway beautifully. Parts of the car show up over a 5-month period, maybe. People show up now and then, sort of at their whim. They assemble it. Someone drives it around the block once, throws me the keys, and says, "Great, we're done." And then my neighbor wants a car, and they have to go through that cycle. So I know if there's any architects listening, they will absolutely not agree with this, or urban planners. But is this all pointing to the direction that we need to be standardizing the insides of these buildings so that we're just, because I think we get rid of the customizable piece, and then the facades can change, and maybe some of the programming can change. But is that where we're headed? And I'll put that to any of you.
I think that thousands of years of architectural direction says probably we just won't ever get there.
Right.
And I think this is why we deal with that truth of we need to accommodate buildings as a reality. Now, I think we'll see more of that. We'll see more of this idea of componentization, because compared to any other industry, it's kind of remarkable that we managed to even make buildings work, but there isn't a process, right? Every project, every building is this one-off collection of all of these different contracting companies. And we really think, that this is the core problem, right? If we can't make that more streamlined, if you can't make the design build process more error-free, then you can't add to that complexity. It's already complex enough. And I think just a point on the car analogy that you made, yeah, it's true that cars go faster and they have a more chaotic environment. But the state space, or the level of inputs and outputs of buildings is higher, and effectively the two problems are the same. So when we talk about autonomous buildings, we don't mean that in an abstract way. Very much, it is pathfinding of looking through a tunnel of time of all the paths that you could take to control all of these systems in a building in coordination. And you're looking at roads and on-ramps and off-ramps and different paths of control, just in the same way you do moving a vehicle through space, we move buildings through time.
And I also want to add that the difference between cars and buildings is we've been only had cars for the past couple hundred years, but we had building for thousands of years. So one of the advantages we have with building is the rules are quite well defined about what makes a good building versus what makes a bad building. So that really gives the advantage to building management in that, well, everything information you need already exists in some forms out there, versus if you're driving on sort of a grass field in a car, you can do whatever you want. There is no rule that guides you how to drive around in a mountain area. But with buildings, how the building should be built and could be built has been around for, there's a building code, there's fire code, government regulations, insurance best practices. It's all existent. And really a lot of that building process is looking to see where do you find the newest rules and new sets of data and best practices and apply that to your building.
And I think the risk in the first statement is that we never want to have an assembly line of buildings that are identical, a city like that where every building is exactly the same. It's a terrifying future. We love to be in interesting spaces. I think, a lot of us working from home, we can't wait to go back into buildings, which are very interesting spaces to be a part of. And that's why architects have that role to kind of create places that inspire us. But there's also on the flip side, the need for us to have a definition language across all of the type of assets that we do have. So there may be 1,000 types of pumps, but we need to understand the differences to each of them. And we need to understand across all the different types of assets, which ones are performing best in my portfolio. It's not that we're going to have just a single pump that will work for all buildings. Each building will have its own unique needs, but we need to understand as well, how can we compare apples to apples and not apples to oranges, which is currently where we're at today. Right.
So I think that leads in well to a question. I've seen a couple of questions come in. They're in the chat. Ideally, if they could be in the Q&A, that would be great, but not an issue. But around the idea of a digital twin standard, is this being developed? Are different, call it brands of digital twin, are they able to speak to one another in a common language? Or is this proprietary, and then we're going to have, when you get to sort of scaling up to a portfolio scale, or to the idea of going to a whole smart city, need to make sure that everything is speaking to one another. So is there a digital twin standard? Is it the digital twin standard itself that needs to be standardized, or is it the communication protocol? And who's working on this? Who's leading that charge?
So I can speak a little bit to that. So we just got a $1.1 million investment from the Department of Energy to go build that standard. I think we're in a unique place in that what the problem we were trying to solve to make PassiveLogic's technology go, it sort of asks the question of what do digital twins need to be over the next decade. And so our goal in this next year or two, we have several industry partners that we're working to formalize our digital twin standard as a external open sourceable formats that we can all use to not just describe the sort of core notions of like what is a part within a building and what is its name, what are its labels, but how to describe these behaviors and actors. And the value of that is multiple things, right? From our point of view, in the near term, we need it to compute this real-time autonomous decision-making. We need it to provide the APIs for our partner solutions. But when you look down the line, for instance, if you're a REIT or a maintenance management firm and you have 1,000 properties, you have a problem today. How do you even compare those properties benchmarked one against each other? Right? If they have no underlying physics description, you can't really, it becomes a PhD dissertation problem to go like do all the statistics many different ways to say, how does a project in Toronto compare to one in Alberta, compared to one in Alabama, compared to one in California? There's just no context, right? And so this is one of the things that PassiveLogic's physics-based digital twins enable. It also enables a really important thing, that if you have autonomous buildings and those buildings are agents of their owners, and you have utility companies and energy grids, we need a way to talk back and forth between one another, from suppliers and consumers of energy, in a way that we can make real-time demand response in these systems that enable basically utilities to say, hey, there's a rate peak coming at 3 o'clock this afternoon. Hey, buildings, go navigate around it before it becomes a crisis. Or in return, buildings to say, hey, here's what my next 12 hours of consumption, because I can compute those futures, will look like, and utility companies can go buy on and sell on the wholesale market. And you need to be able to do this in a distributed way that no one entity can game the other entity, for which these digital twins, as a proof of what you're saying, become a core part of the conversation. So these are some of the conversations we're having with national labs and utility partners, large REITs and maintenance management companies, as well as government entities.
And I would also encourage anyone who's interested in the topic, we're part of a group called the Digital Twin Consortium. Microsoft is one of the founding members. There's a lot of big organizations, Lend-Lease, GE Software, Dell, Autodesk. They're all a part of this. What we're trying to do is, we understand there's lots of these conversations happening, which is great. You know, we've defined that that's a problem. So we're all trying to work on it. We're going to converge at some point, but everyone is coming to the table, I think, now to understand how do we create that standard language. And in the future, let's say 5, 10 years from now, there needs to be a single one. So all of us can be in an open marketplace where we can actually apply a lot of value to owners, because participation is going to be key and cooperation is going to be key. And as groups like Microsoft builds the world's computer using Azure Cloud, they're actually building out Azure digital twins. And hopefully our businesses can become the interface to that digital twin for our customers.
I also want to share that the way to build for standard is now can be now a lot different. The challenge of the standard is who gets to own the standard, right? There's many people that want to be, I want to put a standard out there. I want to put a standard. I used to be in the virtual reality space, and that has to end up being the issue, is that there are 5 standards out there. Who do you follow? And I think it's also good to think about how do you design a dynamic standard that takes in data and dynamic optimizes itself, so that when every system is connected to the same style as a dynamic standard, when the standard change, it automatically adapts the system for you. So that instead of having someone to manually going and process all the standard, reads all the standard, and trying to change your system, there needs to be a way to automatically, okay, so if the standard updated 2 months ago, it automatically updates itself for you, so that your system is now more dynamic. This is the way that's being done in the software right now. The software also faces the same issue, but now it's you putting different plugins that will automatically test your code for standard and make changes according to it.
I think Jack's point is an important one. If anybody in this space hasn't seen the XKCD cartoon of the 14 standards, and then the guys are like going to make the one standard to rule them all, and now there's 15 standards. You know, I think the important thing here is, and I think how we think maybe a little differently than a lot of those standards approaches is that we're less interested in the serialization of or the semantics of the standard as much as what is the fundamental meaning of the things we're talking about. And those can then translate into multiple like semantics, right? So you can support multiple standards, multiple protocols, and that can happen on the IoT side in the building, and that can happen on the serialization side on the top side.
Great. So there's one other question that has popped up that I would love to ask, and we have 2 minutes, so it'll have to be pretty quick. But given this is still early days and there's a lot of technology out there, but trying to get it implemented on the building side, who is this on to make the market for it? Who's going to be buying and investing in all this IoT, especially when things may be obsolete really quickly? So are we looking to industry? Does government need to lead it? Is this one of the big spends potentially that comes out of COVID to help get the economy back up? Any thoughts?
I might just jump in, give my 30-second view on it. I think it has to start with the owners. When they demand change, then the industry moves with them. We noticed that quite a bit when we noticed there was a few dinosaurs in the industry that were very closed. And now we're moving to a very open ecosystem in terms of data sharing and giving data back to the owners. And that's when a lot of players like ourselves can add a lot of value. But that's maybe just my view in 30 seconds.
Yeah, so I'll give my quick 30 seconds as well. So I think the short answer is everyone. If there's a misalignment in terms of building stakeholders, project doesn't go through and it gets delayed and certain changes are put off. And if you look at what happened with Sidewalk Labs, that turned to be, one of the reasons why it didn't end up going through, even though Google's really following on the solution.
Mm-hmm. And again, why I agree with all those points. I think as a company, we're focusing really on that bottom end of the doers, so to speak. And that just starts with the view that they're the people already buying the equipment that makes our buildings go. And the equipment, to your point, it's already 100 years old, right? So the fact that things are changing every 5 years, it really doesn't matter. You're comparable as a very, very low bar. So I don't think that that's a crucial challenge that's that technology will be better in 5 years when the comparable last year is basically the equivalent of something invented in 1850.
Right. That's a good point. And a good way to wrap that up. It's 12, so I sense our time is up. So hopefully this is still broadcasting. But so thank you everyone for joining us today. Especially thank you to our panelists, Ryan, Jack, and Troy. It's been a great conversation. There is pages and pages of questions that I had that we didn't even get to. So I encourage anyone who's watching to reach out to all of you. If you have any direct questions, want to follow up, explore more about their companies and offering, and have a great day. Thank you.
Thank you, Brad.
Thank you.
Thanks.
Thanks, guys.